This week on Made in SA, we're in Tsakani with a girl who dreams of solving technical problems for the greater good.
My dream is to become a successful chemical engineer.
It's one thing to want it, but is Carmen made of the right elements to effervescence her way to the top of the test tube?
First thing that you need to have to be a chemical engineer is you need to have strong technical know-how.
This is how we roll. We celebrate young people of excellence and get them closer to their dreams.
My name is Carmen. I'm 18 years old and I live in Tsakani. My hobbies are drawing as well as listening to music, and that's the stuff that I do during my spare time. My dream is to become a successful chemical engineer. I'd really love to be an engineer because since grade 10, I've had an interest in engineering. I would describe myself as a very caring person, ambitious as well as creative and funny. I love drawing because that's how I express how I feel. I love everything related to science, mostly medicine. I love sweet stuff. I love food because it tastes very good. And I love comedy. I have a great sense of humor. The special people in my life are my grandmother and my mother. My grandmother's very talkative. She always makes me laugh. I enjoy spending time with her and I enjoy being with her. My mother, she's a very quiet person. We like laughing. She's a very understanding mother and we have a very good relationship. And they are special to me because they've raised me to be this great young woman that I am today.
My name is Naomi. Carmen is my daughter. Carmen has been an angel from birth. That's why I call her Angel. She's passionate about people. She doesn't want to see anyone get hurt. That's why she opted to become a scientist or an engineer so that she could be able to help people.
My name is Bikaravela Balance. Carmen is a very good friend. She's quiet. She's not much of a talker. She's understanding and she's a shoulder that you can cry on if you have a problem.
My name is Israel Ramtietsana. Carmen is my friend. Carmen is a good friend. She's funny. She's full of exuberance. She's hardworking.
I think Carmen's flaws are she can't sing, but she loves singing. We always make fun of her. So I think that's one of her flaws that I've noticed.
She loves making fun of people. She always makes fun of me.
What irritates me mostly is when she makes jokes. Even though she is to be serious, she just loves laughing at other people. She never gets serious unless she has to.
What I really love about Carmen is passionate, she's open, and she's a good friend also.
Her attitude towards other people. She's a good person you can talk to. She's a person you can depend on with whatever you have a problem with. She's just amazing. She's like a sister to me.
I think her dream of becoming a chemical engineer, she made a good choice because she is passionate about it. She does not care about the money in it. And she's willing to put her all.
Carmen's dream of becoming a chemical engineer is a very good idea for her. I know that she's a hard worker, and if she has a problem that she can't deal with by her own, she always finds a way out. She's very passionate about her schoolwork. She believes that anything is possible.
She means the world to me.
She also means the world to me.
When she was a child, she used to take stuff in the cupboard, mix them all together, trying to make a bomb. I don't know if she was making a bomb or what. And it would not explode, and she would cry. That's all I remember, the funny story about her.
The thing that made me decide to follow this particular dream was the fact that I loved science since I was a child. I used to watch a show called Hip to be Squared. That's where I got interested.
I think I dream of becoming a chemical engineer. It's a good dream. She can do it, I know.
The compulsory subjects for pursuing chemical engineering are physical science and mathematics.
She loves studying. She's a hard worker. And she likes exploring. She wants to help people. She wants to find cure for some of the diseases. She's proactive, in fact. That's who she is.
I think it's important to follow my dream because it will make me feel that I've achieved what I wanted to achieve.
Carmen, keep on following your dreams. Anything is possible with God.
After the break, our explosive dreamer Carmen will meet her coach and experience firsthand what concoctions she needs to become a successful chemical engineer. Welcome back to Made in SA, the show that's all about rolling with Mzansi's most ambitious peeps. And it's time for Carmen to meet her coach.
My name is Anthony Higginson and I'm a chemical engineer. Well, the first thing that you need to have to be a chemical engineer is you need to have strong technical know-how. You need to be able to work out how things actually work. Then you need to be able to have the perseverance to actually sit down, look at a process and figure out where you can make improvements and how you can actually make the process better and more efficient. What I really love about chemical engineering is it allows you to make a tangible difference in the world. You can actually take a raw material and turn it into a product that is more valuable and actually gives something to the economy and actually grows the country. And also, especially in the modern world where environmental issues have become much more important, chemical engineers are very well placed to make sure that processes become more environmentally friendly and actually prevent some problems that might be coming up in the future. Well, I think people don't really understand the term chemical engineer properly. When they hear chemical, they think chemistry. And that's a little bit of a misconception because it's not really based on the chemistry, it's based around the mathematics. So you need to look at a process and then mathematically derive what is the best way for this process to actually occur.
Today I feel very excited because I'll finally be meeting my coach and I'll finally be getting information about chemical engineering. I'm about to meet my coach. I feel very excited. I do not really know what to expect, but I have a very good feeling about it. It'll give me more information about chemical engineering and I desperately need that. I'm looking forward to meeting a chemical engineer because I'll be able to ask him more questions and I'll be able to get more information regarding my dream career.
Hi, Carmen. I'm Anthony Higginson. Nice to meet you.
Likewise.
Take a seat.
Thank you.
So, why do you want to be a chemical engineer?
I love chemistry a lot. I love physical science, and there's a huge demand for chemical engineers in the country, so that's why I want to be a chemical engineer.
Well, what do you know about chemical engineering?
I know that you manipulate raw materials in order to make items of value and usable materials.
Okay, well, I have a challenge for you today because we'll be doing a process whereby we're converting starch into sugars. And we need to see what is the actual conversion of these starches into the sugars. So I want you to calculate our efficiency for us.
Okay.
So if we're looking at our percent efficiency, that's going to be equal to the mass extracted over the mass of our grain multiplied by 100. So we're going to know what the mass of our grain is because we can actually weigh the amount that we're putting in. But when we're looking at the mass of our extract, it's going to be equal to the volume of the liquid we get out, multiplied by the specific gravity of the liquid that we get out, and then multiplied by the degrees in Plato. And that can be approximated by having an equation which is Sg minus 1 over 0.4. And that should give you the mass that is actually extracted from your words. Okay, the reason we want to calculate this efficiency is because we want to see how efficiently we are actually using our raw materials. So you're also going to have to do some tests as we go along to make sure that our conversion will actually be occurring properly. So you're going to have to check that the pH is actually in an adequate range, so that's not affecting our efficiency, and that our conversion is actually moving along properly. So you're going to have to do an iodine test to test that there's no more starch present, and you're also going to have to check that the pH and the temperatures are in an adequate range for the conversion that we're looking for. Okay, this is important because we're looking at how can we get the most efficient use of the raw materials that we're actually using today. Because if we're not getting a good efficiency out, it means that we're not utilizing our raw materials to their full capacity, which of course means you're wasting stuff.
So what is the optimum efficiency rate that you're looking for?
The best efficiency that we could possibly get with the grains that we're using is about 78%, because that's as much of the grain that is actually starch. So we're looking at a rate somewhere around about 70% would be a very good rate for us. However, anything below that we would look at trying to improve in terms of getting our process working better. This is also an important process because this enzymatic breakdown is used in various industries, including the production of biofuel. So where they have a starch base and they need to actually break it down into sugars. So that's why we're looking at this process to try and get fermentable sugars out that can then be fermented to produce ethanol. Okay, well, we're ready to get started. Are you ready for this challenge?
I'm ready for the challenge.
Okay, let's go and meet the rest of the students.
Converting starch to ethanol while measuring pH, conversion rates and efficiency? Piece of cake. More like plate of porridge. Welcome back to Made in SA, where we get up close and personal with the nation's passionate dreamers. Earlier, Carmen got one step closer to her dream when she walked into the pristine and precise world of chemical engineering. But Carmen will soon discover that working in a lab can sometimes feel like being in a kitchen. Let's find out why.
Okay, grab a lab coat and then we'll be able to get going. Okay, Carmen, the process we're looking at today is breaking down starches into fermentable sugars. So if you look here, this is our malted grain, and you see it's very hard and encased in a husk. So we're not going to be using that today because we've got this grain here, which you see has already been ground up, so it's almost like a flour. So the first thing I want you to do is weigh how much grain we're actually adding into our mash. So you're going to have to weigh this, and then once we've used up everything and put it into our mash tun, you're going to have to weigh the container, and then the difference will give you the amount of grain that we've actually used. And then write down what the weight is. My first impression of Carmen was that she was a little bit kind of withdrawn at the beginning and didn't really know what to make of things, but as the day progressed she did seem to start enjoying the activities a bit more and came a bit more into the challenge and picked up the challenge as something that she wanted to do. The process we'll be looking at is the chemical change of starches into fermentable sugars. So we'll be starting off with grain, and then using an enzymatic process to actually break down those starches into sugars that can actually be fermented by yeast.
Yeah, it does, eh?
Smells like porridge.
Looks like oats, though. Looks like oats.
Well, it's probably better to do the first part of the challenge now. So what I'm going to have you doing an iodine test. It immediately turns this blue-black color. That means there's still starch in there. Every 5 minutes from now, just take a small sample like that, put a couple of drops of iodine, and then we can see when we've got a full conversion, because what we're looking for here is the starches to change into sugars. So once this stops turning black like that, then we know that we've got that conversion.
What I hope to achieve today is to get practical experience as to how a chemical engineer's day is, and to be definite that this is the career for me. This is fun.
Yeah, so just take that and do a drop on it. Yeah, so you can see that now it's staying brown, so that means that there's no starch left, so we can carry on with the rest of the process. Okay, so we're measuring the pH, and the pH is very important because the enzymes are very active at different pHs. So if the pH is too high or too low, the enzymes won't be active and we won't get that breakdown from starch into fermentable sugars.
Looks like a 5.
So probably 4.8, 4.9, but nearly 5. But that's the exact range that we're looking at in terms of the best pH for the enzyme. So that's exactly what we're looking for.
So will the yeast be added immediately after it's transferred into that tank?
Well, it's still too hot at this point to add the yeast. So we need to take it from here, cool it down, and once it's in the fermenter at a temperature of about 17 degrees, then we can add the yeast. Okay, so you're going to have to measure the level of the liquid that we've just transferred out of our mash. So then you can work out the total volume of liquid that we've transferred. So you can take this and then put it against the wall of the tank, and then you can see how much liquid is actually in there.
I do not think that I'll stop having the dream of becoming a chemical engineer, and I'm sure that I would have learned something from today's experience.
My impression of Carmen was that she took to the practical aspects very well, in terms of doing the iodine test for the starch conversion, in doing the pH testing, and for the specific gravity as well. And she also took quite a bit of time to try and understand the process that we were doing in terms of this enzymatic conversion. Her only problem seemed to arise in terms of the formulation and the mathematical background to actually calculating the efficiency, where she had a couple of problems.
Anthony?
So what is the value that you got for your percent efficiency?
I got 58,819,06, and that's quite a big number.
Yeah, well, it means that you got several hundred times more out of your grains than you started off with. I think you can figure out where your problem is.
Nothing looks wrong to me except the answer.
Now, well, one problem you've got is that your units are wrong, because your SG would be kilograms per liter, whereas your volume that you've calculated here is in milliliters. So that's why you've suddenly got a much higher, because this is actually 128 liters, not 128 milliliters. So if you divide it by 1,000 to go from liters, milliliters to liters, then you'll actually get a percent efficiency of about 58%. And the maximum you could get is about 78%, and that's if you take everything out. So that's not a brilliant number for us, but it means that we still have a bit of work to do in terms of getting our efficiency up. Okay.
But it's not that bad though.
Yeah, well, apart from your units, your calculation was fairly correct. You've got a little bit to work on your maths.
Yes.
But in first year, they spend 6 months teaching the students this thing about units.
Okay. Working with my coach Anthony was very fun. He taught me a lot, and he was very patient, and he was very understanding. I learned quite a lot, thank you. I enjoyed my day here. I wish I could spend the rest of the day here. Thank you very much.
Well, thanks for being here, and hopefully you put in some hard work, and we see you here back as a student.
Surely next year I'll be here.
I think what she needs to do is actually do some extra maths courses, really get into it and learn those mathematical basics, so that if she does get into chemical engineering in the future, she won't struggle with any of the mathematical concepts that will be taught during the course. I thought she was quick, she was keen, and she did seem that she is quite intent on becoming a chemical engineer. She may have a slight misunderstanding of exactly what a chemical engineer does, in that she was saying that she really enjoys chemistry, and chemistry is very little of what a chemical engineer actually ends up doing. However, I think if she does a bit more research, she might be able to find out quite a lot more about exactly what chemical engineering is and what is required from a chemical engineer. My message to Carmen would be that she showed herself to be very keen, very eager, and I'm sure that if she puts her mind and effort into it, she will be able to succeed, and we'll see her as a chemical engineering student in the future.
My day was very awesome. I had a lovely day. Anthony taught me about chemical processes, and today he taught me about fermentations. One thing that I loved the most was being in a laboratory. At least now I have experience of being in a lab. But one thing that I found very challenging was the mathematical side, the challenge, but it was fun though. Today's experience has made me more determined to become a chemical engineer.
Whip that maths into shape, Carmen, and nothing will stop you.